Last time we discussed about cyclic plate load test. So, basically once again I am repeating this test stimulate traffic conditions by repeated loading, traffic conditions by repeated loading, and loads applied in cyclic manner, I mean loading and reloading. It basically establishes the progression of accumulated deflection due to both elastic and as well as permanent deflection. The load cycle curves gives the bearing value of any particular deflection. So, determination of deflection modulus and bearing. The idea of doing the cyclic plate load test is to find it out deflection modulus and bearing value for particular deflection. Now, if I show it, this is a typical load settlement curve. If you look at here, from here to here, load has been applied by means of hydraulic jack. Then once it get stabilized, then there is no more deflection by the dial gauges. Say the rate of deflection is about 0.02 mm per hour. Then next step, instead of applying this, suppose this is first increment, this is second increment, this is third increment, this is your fourth, this is your fifth, this is your sixth. So, next step, applying the second increment, entire load has been, means it has been unloaded, entire load has been released. So, this is the part of release, you can say this is the part of release. So, once it has been released, the displacement has been recorded by means of dial gauge. Then after release, then next increment of load you apply increase up to 2, then it will proceed the path this. That means before applying second increment, so first increment of load 1, then it has been means unloaded. Once unloaded, second phase you reload it up to second increment, that is your 2 kg per cm square. Once it is achieved second increment, again as per the procedure, again you unload it, you take it out second 2 kg per cm square. So, then it will bounce, it will rebound and you can find it out how much is your settlement, then again you do it. So, loading and unloading case, if you go like this, so what will happen, you will find it out that there are up to certain level, there are up to this, there are two parts you can get it. One is your elastic deflection, means the deflection where I means once you load it, then you unload it, it is supposed to return back to its original position. So, this part up to this, if you look at here, this to this, if I take it any part, here it is coming back to the original position. If you look at here at the third increment, it is not coming back, once I reload it, it is not coming back to the original position. So, now once it is not coming back to the original position, so what will happen, this is my, if I take an example, this is the starting from where this load increment has been applied, then it has been unloaded. So, from here to here, this is called elastic deflection, as it is not reaching to its original positions. So, this is called permanent deflection, and beyond this you can say that elastic and permanent deflection. So, you can from this means cyclic load test, you can find it out accumulated permanent deflection, accumulated load deflection from there, then accumulated rebound, how much accumulated rebound. If you look at here, how much accumulated rebound. So, from here to here, look it here, this is the position where and this is the position where, and this is up to this, once it has been unloaded, this is my rebound. Similarly, in this case it will be, this is the rebound. So, it has advantage, because what happen in traffic load, it is a load which has been applied by means of if you look at here, repeated loading means traffic in a road, there are passage means repeated loading, how it comes into picture. Suppose for example, one truck or one bus or one vehicle it passes, say it passes now, maybe after certain period of time, say 2 minutes, 4 minutes or 6 minutes, maybe 1 hour, same kind of load or same truck passes. That means it allows, this is my road surface, this is my road surface, it allows impact load at certain interval of time. That means whatever load coming here, then after certain interval it applies also same, then same. This is called kind of repeated loading applied due to traffic conditions. So, what will happen once the load has been applied, it impacts the load once vehicle passes. Suppose the vehicle passes here, vehicle passes here. So, what happen? It apply load, then once vehicle goes, then again it will kind of think, once vehicle passes it will apply load, once vehicle go, this will again what will happen, there will be rebound, then again vehicle will be there, then again it will be there, then once vehicle will go, there is in the road there is no load, once the vehicle passes there is no load. So, what happen, the soil again it will be rebound, then another part of this vehicle passes, again it will be go, means then again one vehicle passes, then this is rebound. This kind of particularly this loading and unloading means how much deflection accumulated, both elastic as well as permanent deflection, both elastic as well as permanent deflection, you can find it out, and it has a meaningful, means in this road base, if there is a repeated loading by means of vehicles, what is that elastic deformation occur, what is your permanent deflection, means after this elastic deflection, what is the permanent deflection occurs, that is required, this permanent deflection is required for design of this road pavement and road. Now, if you look at here, so this is my permanent deflection, accumulated permanent deflection, this much is your permanent deflection. So, this permanent deflection you have to identify by means of repeated loading, this deflection whatever achieved by vehicle, this permanent deflection it will not bounce back, it will be there in this road surface or pavement. So, this is all about this cyclic plate load test. Now, go to the next page, this is interesting, this is another, it is called pile load test. Pile load test has been performed in the field to find it out pile capacity. This is one of these tests has been conducted in our Geotechnical Engineering Laboratory, IIT Kanpur. This is pile under axial compression. If you look at this figure, my pile is here. What are these piles? Now, before I describing this completely pile load test under axial compression, then what are these piles? You see, this is typical of a pile of diameter 0.4 meter and length has been taken as 4. So, L by D is equal to 10, L by D is equal to L by D length to diameter is equal to 10. So, pile material has been constructed with M20 grade of concrete and steel is Fe 415 grade of steel. So, the construction technique is it has been done by means of cast in situ board piles, by means of cast in situ board piles. If you look at here, the bore hole has been made by means of hand augering with this helical blades. These are helical blades. I'll also show later on how the augering has been done. Once this augering has been done, bore hole has been done, then this pile material, pile diameter with this casings has been prepared outside by means of a circular of pile size of L by D 10 and diameter is equal to 0.4 meter, and these are my longitudinal bar, these are the shear bars or transverse bars, it has been provided outside. Then once the bore hole has been made, inside this bore hole the entire casing consists of steel a longitudinal bar as well as circular bar and making a diameter. This is my diameter of 0.4 meter, 0.4 meter. It has been pushed inside this ground. It has been pushed inside the ground. Once it has been pushed inside the ground, then what will happen? You prepare concrete. You prepare concrete, M20 grade of concrete you prepare. Then this concrete you pour inside, so that what will happen once you pour inside, this will become reinforced concrete of pile. So, why it is called cast in situ board pile? So, there are three kinds of piles. One is driven pile, one is cast in situ board piles. I mean, there are different classification. If I make it into two parts, one is cast in situ board pile, other is your driven pile. In case of cast in situ board pile, the meaning of cast in situ means the casting has been done itself in the field. The casting has been done, casting of the pile has been done itself in the site. If you look at here, in the site boring has been done. After boring has been made, in site itself entire preparation of this casting of the pile has been done. Then that is why it is called cast in situ board pile. Then casting of pile has been done. This pile has been inserted, placed inside the board in the field. There is nothing, you bring it outside. What happen in case of driven piles? You bring pile outside, like concrete pile you prepare somewhere else and bring it back from outside. So, again in the field you drive it. The moment I say it is cast in situ board pile, that means everything has been done in the field, casting, boring, casting and placing pile inside the borehole and placing this concrete inside this borehole. Everything has been done, in the field. So, sometimes we prepare also, sometimes people place also strain gauges inside this pile. So, this is one of the part of the research. So, strain gauges along the pile, along the length of the pile. Suppose this is my length of the pile, sometimes we provide strain gauges along the length of the pile, so that stress transfer as well as strain, particularly strain transfer along the length can be measured. Once you strain transfer you measure, then you can say that the load what is the coming to the pile, how it has been transferred to the ground surface or transferred to the pile as well as soil, pile soil interface, how it has been transferred. Now, this is case 1, pile load test in case of pure compression. So, what happened? Initially pile has been means cast in situ board pile has been made. So, here cast in situ board pile has been made. Then with this, these are 4 anchor piles. If I draw how this phenomenon, how suppose this is my pile has been constructed inside the ground. So, what happened? There are reaction beams opposite to each other. So, it has been, the reaction has been taken by means of anchor piles. So, if you look at here in the figure clearly, this is one anchor pile, this is another anchor pile, opposite to that this is one anchor pile and somewhere else there is anchor pile. So, what happened? First these are called girders. So, what happened? Initially one girder has been placed over the pile by means of hydraulic jack. If you look at here, this is my hydraulic jack, this is the hydraulic jack. So, what will happen? So, above the pile head, prepare a pile head, this is the pile head, prepare a pile head, then after the pile head, above the pile head place one hydraulic jack. Then in the pile head, if you mark it, there are 2 dial gauges opposite to this pile head. It is diametrically opposite, means if this is my diameter, this is opposite, one dial gauge here, so that you can measure the displacement. Then after placing this hydraulic jack, after putting hydraulic jack in the pile head, in place one girder, this is one girder. So, now after placing hydraulic jack, place 2 dial gauges at the opposite diametrically opposite, so that both the ends you can find it out how the displacement or settlement vary. Then after placing it, you place one girder here. This dial gauge you can place it after placing all the girders, because initial phase it will settle because of self weight of girder. Initially what happen, you place this one girder, then this girder, first this is girder 1 and this is girder 2. This first girder has been connected by means of bars, reinforcing bars of the anchor pile. If you look at this is my anchor pile. With this anchor pile, whatever the bars, these are main longitudinal bars, main bars of anchor pile. So, these main bars of anchor pile has been tied in girder 1, and at the opposite end also it has been tied with girder 2. Once one girder has been placed, so initially what happened, before placing, after placing in the pile head, there will be a gap from the ground. It has been placed because this height is a gap from the ground, so it may fall. To make it symmetry, some sandbags has been provided, so it makes symmetry, it placed in horizontally. Then what will happen, after placing one girder, you can place second girder. So, second girder. So, basic principle is whatever load coming to the pile, so it will taken by girder 1 as well as girder 2 by means of pile anchors by four parts. So, after placing this same way you can place the girder. Here also the main reinforcement, main bars of pile tied with this girder. So, these girders has been crossed 90° to each other, it has been placed, and to making symmetry also second girder, some sandbags has been placed both the ends. This is stage 2. After you provide this, then stage 3 you wait for some time, so that whatever displacement has been achieved by self weight of girder, you can leave it. This is as a dead load. Then after that you place you take the reading from the dial gauges by means of hydraulic jack. So, in this hydraulic jack what will happen, this hydraulic jack is there, it has been connected somewhere else, and here also there are some wires are coming where you can measure also strain gauges, strain rate you can measure. Here you can apply pressure to this, hydraulic jack. So, you apply the pressure intensity, suppose you apply 10 kg per cm square. So, what will happen, it will try to make this, once you apply pressure to this girder, it will try to make uplift, make up to the girder. So, this girder will go up and it will rest against this anchors, pile head anchors. So, each action has equal and opposite reaction, as I said. Once it rests against the pile anchor, so it will apply load indirectly downward, so the pile will settle downward. Then each load increment you apply and wait for this, how much is your, continuously you apply this load 10 ton per meter square or 10 kg per cm square, it will be applied. You maintain that pressure, so that you observe this, how much is your dial reading. So, initially dial reading is, you are continuously taking the dial reading. After certain time you will find that dial reading will be like 0.02 or maybe 0.01 mm per hour. Remember, the moment you start this pile load test, you cannot stop any time in between, it will be continuous process, So, that means once you applied, suppose say you applied like 10 ton per meter square or 10 kg per centimeter square, continuously you apply pressure through this hydraulic jack. So, 10 kg per cm square or 10 ton per meter square, if you apply the pressure, you measure this displacement by means of dial gauge. So, displacement is increasing, you just record it and wait. Once the displacement will reach 0.02 or 0.01 mm per hour, you stop at that point, and that is your final displacement for your load intensity, say 10 kg per cm square or 10 ton per meter square. Then you apply your next load intensity. Like this you continue till pile fails, or as per IS standard whatever you will get it, up to that you can go, so that you can plot load versus displacement. Now you see, this is the procedure, just it is written. The test was carried out by applying series of vertical downward increment load, each increment being in this case 24 ton, in this case whatever I have shown our geotechnical lab this test, it is of 20% of safe load. That means before starting the test you take the pile and find it out theoretically what is the bearing capacity of pile. Then from this bearing capacity theoretically you can find it out what is the safe load of this pile. Once you get the safe load theoretically, then each load increment should be 20%. That means suppose you are taking 200, so it will be 20% fast start. You can start with this 40 ton or 40 kg per cm square. So 20% of safe load every time you have to increase. So this is where how it has come from theoretical calculation. Then application of increment of test load and taking measurement of displacement in each stage of loading is maintained, as I said earlier, till rate of displacement of pile top is either, you see, 0.1 mm in first 30 minutes or 0.2 mm in first 1 hour or till 2 hour. Which occurs first? Look at the sentence, which comes first. That means how do you stop, how do you, from where you can decide next increment of load can be applied. So you can decide based on that. First one is 0.1 mm in first 30 minutes. Are you achieving first 30 minutes? Suppose this is my dial gauge. So within first 30 minutes are you achieving the displacement of 0.1 mm? Are you achieving? Yes. Then or you, if you are not achieving, you wait whether you are achieving 0.2 mm in first 1 hour or you wait till 2 hour, whichever comes first. That means if this is coming fast, then you can stop. If this is coming fast, then you can stop. This has the meaning. That is the stop point, or maybe that point where you can apply next increment of load. Then the limit permissible displacement was taken as 12 mm, and so the test continue till it reaches that displacement. So permissible displacement as per IS code, you can go up to what displacement? You can go up to 12 mm displacement, so that you can, before 12 mm displacement you can get the failure of, or if you are not getting this failure, then you can go up to 12 mm of displacement. You see, it is written very clearly as per IS Indian standard 2911 part 4 2006. Safe load was calculated as 2/3 of final load, at which total displacement attains a value of 12 mm. If there is a pile load test, as per IS code it says from this pile load test, safe load was calculated as 2/3 of final load, at which total displacement attains a value of 12 mm. If I plot load versus settlement, whatever I got it, first increment, second increment, third increment or fourth increment, whatever I got it, if I plot load versus settlement, that means it says as per IS 2911, safe load was calculated as 2/3 of final load, at which total displacement attains a value of 12 mm. First take 12 mm of displacement, then with correspond to 12 mm in displacement, what is that load? Say 12 mm of displacement, say load is equal to say 20 ton. As per IS code, 2/3 of final load at which total displacement attains a value of 12 mm, that means I will go 2/3 of 20, which is equal to your safe load. So, that means you go up to settlement, when once you attain that settlement, either the pile fails, or if it does not fail, then what will happen, you wait up to the settlement of 12 mm. Once the settlement 12 mm has been achieved, the corresponding load will be taken, and 2/3 of this load is taken as safe load of this pile. I hope now this is clear. These are the two major parts. One is your where you stop, at what point increment of load, second increment or next increment of load you are going to start, or where you will take the displacement reading. It says, like as I said, once I am repeating, 0.1 mm in first 30 minutes or 0.2 mm in first hour, whichever comes first. That means which one comes, you can see which one from this dial gauge displacement, that you take it. Other is the limit permissible displacement was taken as 12 mm. So, why did 12 mm has been taken? It is based on that, as per IS 2911, safe load was calculated as 2/3 of final load at which total displacement attains a value of 12 mm. That means up to 12 mm, what is the load coming, that load 2/3 you can consider. So, that 2/3 is your safe load. This is another typical arrangement. That arrangement was pile load test with a compressive load. This is typical arrangement. One is your pile load test to get what is its tensile capacity or uplift capacity. This is pile under simultaneous uplift as well as compression capacity. How this test can be performed? If you look at here, this is specially designed at IIT Kanpur in this workshop, so that we can measure this load versus we can measure this piles under, means uplift capacity of pile. Here also this pile load has been measured with the help of static compressive load or stage loading. I will stop it here with the next.